All right, so this is for worksheet 12.2. I'm going to do this in two parts. So this is going to be part one, which is basically a quick review of what we've been doing so far. Kind of hopefully help wrap your head around a few things. All right, so first off, putting vectors in standard form. Okay, so basically, if you have your point here, whatever you're referring to, and you have a line this direction here. So if you have 2 points, it's a point A of x comma y comma z, and point B x2 comma y2 comma z2. So therefore, if this is A to B, so you have to make sure you subtract B first. So x2 minus x1, y2 minus y1, and z2 minus z1. Okay, notice my notations, which basically represents the slope, or basically slope with direction. Okay. All right, so again, so if you have an example here, say A to negative 3, 4, and I'm going to B, 5, 7, negative 5, then AB, okay, be 5 minus 2, 7 plus 3, negative 5 minus 4, and therefore you have 3, 10, negative 9. Okay. Now, if I wanted to find the magnitude of, say, the magnitude of AB. So again, notice the notation there, or that's Pythagorean theorem. So you have 3 squared plus 10 squared plus 9 squared. Okay. And that would be root 190. Now this last thing was a unit vector. I'm going to talk a little bit more about this in a second. But the unit vector E, and this is, let's say, I don't want to represent it. Let's say this is V here, make it easy. So the unit vector V would be 1 over 190 times 3, 10, negative 9. Oh, excuse me. Okay. So, so if we looked at, say, the unit circle. Now remember, the unit circle has r of 1, so like this point here would be 1 comma 0. This here would be 0, 1. So if I have a vector going beyond that, and let's say this is, let's use something really easy, 3, 4. Okay, I have to shrink that down to a length of 1. Okay. Okay, to do that, I got to know the distance. So d squared equals 3 squared plus 4 squared. In this case, d is 5. Then divide by that. So now I have, if this is, let's say, t here, my unit vector of t would be 1/5 of 3 comma 4. Okay. Now, if I want to extend the length of this, so let's say I want a distance instead of 5, let's say a distance of 7. Okay, what is that vector? So therefore, if I now want to extend this out to a distance of 7, then all you have to do is take your unit vector and multiply it by 7. So basically this would be 7/5 of 3 comma 4. Okay. So if I put the question something like this, so hopefully that's wrapping your head around this. Let's say if the magnitude of A is 40 newtons with a direction of 2 comma 3 comma 1, then find the components of A, okay, with that same direction. So to do that, you have to come back to what's the unit vector of this, okay? So if I find the magnitude of that, so therefore, let's call this, I don't know, let's say T, well, let's say T here. So let's say T is represented by 2, 3, 1. Therefore, the magnitude of that would be 4 plus 9 plus 1. So that'd be root 14. So that would mean the unit vector of T would be 1 over root 14 of 2, 3, 1. So if I want a new length of this, and it says magnitude of A, so with the magnitude of A being 40 newtons, and I want to go with the same direction as this, all you have to do then is multiply the vector A, magnitude of A, times the unit vector of T, so that'd be 40 over root 14 of 2, 3, 1. And there you have it. Okay, so now you have the components for A in that direction. Okay. All right. Let's look at one last thing I want to review. Okay. First off, let's say, what I want you to do here. Find a parametric equation for the line with a point of P3, 1, 4 with a direction V of 2, 1, 7. Okay, so again, make sure you don't get mixed up with a plane. So we're doing a line here, not a plane. So this is the same thing as, like y equals, you can either think of it as f of a plus my slope of x2 minus x1, or you can do it the other way, your slope, x2 minus x1 plus f of a. You'll see me switch this around quite a bit. So it's the same equation you've been doing since Algebra 1. So if you write an equation RT, so if you do your point first, you have 3, 1, 4. That's what you start with your direction, 3, 1, 4, and go by time. Now remember, we will have to be able to separate these. So your x component would be 3 plus 3t, or again, you can write it 3t plus 3. Your y component, 1 plus 1t, and z component, 4 plus 4t. Excuse me. Did I use the same? Oh, bad. My bad. This is 217. I wrote down the same thing. So my slope here is 2, or 2t. Thought there was something weird there going on. Y is fine. Z is, is 4 plus 7t. Or again, you can go 7t plus 4. Okay. Okay, and then one last review question. So if you have point 1, let's say 1, 3, 2, to the second point of negative 4, 3, 0, and again you're writing the equation, you got to have your slope, or you're going to see it as written as direction. Okay, so your slope would be negative 4 minus 1, 3 minus 3, 0 minus 2. So again, make sure you use the correct notation. So you have negative 5, 0, negative 2. And since I'm starting with this point here, my r of t would be 1, 3, 2. My slope, negative 5, 0, negative 2, and then t. Okay. All right, quick review of all that. And next video will be talking about where two lines intersect at a common point. Okay, we'll talk a lot more about that. So it's going to come into question when you have it say R1 and R2. You know, they're going to intersect, but this is going to might intersect at time, let's say 2, but this one is going to intersect at time, let's say 4. So they're going to be at this spot at different times. So we're going to have to make sure if we do a second equation that this might be time 1 and time 2, that we got to keep them separate. Okay. So that's the next video, talking about how that is done. And